All right, to this point now, we've talked about several different ways of solving a system of equations. We can do it graphically, using substitution, elimination. We could also use matrices. We could use matrix equations to solve for these variables. Another method available to us is known as Cramer's rule. And Mr. Cramer looks like this. He has a very nice wig. And I don't know, what's your guess? Is that a UFO? Every single picture I find online has that little white dot right there. I don't know, you go figure. But anyway, that's what he looks like. We'll leave him up there for some moral support. And like I said, Cramer's rule is used for solving a system of equations. Okay? Well, here's his rule. Now, if we just have an x and a y we need to solve for, we're just going to be focused. Oh, that's not what we want. I wanted this. If we're solving for x and y, we're just going to be involved, dealing with these two. But if there is a third variable, we would be using that. You can have infinitely many variables. You just follow the same procedure. All right, well, what do we got here? The d on the denominator, these d's right here, they are the determinant of whatever matrix they gave you. Determinant. Okay? So we've talked about how to do 2x2s and 3x3s, and you can, apply that to a 4x4, etc., etc. What do these numerators mean? Well, I have a little d sub x and a d sub y and a d sub z. For right now, let's just, let me change the color. Let's say that this is, well, think about this. All right, we've been doing matrices now, and we've been putting the coefficients for the x values there, the y values there, and in this case we have a z, so we would have a z column there. That would be the coefficient matrix. Well, we also talked about having the answer matrix, right? We set that equal to another matrix on the right, and that was our answer matrix. What we do, just for argument's sake, let me call that A, B, and C. What we do for d sub x, we would take this answer column and we would substitute it in for the x values. So then whatever those numbers were, we would then plug in the numbers from the answer matrix. And then we take the determinant of that matrix, and that is d sub x. Likely, or similarly, if I should say, we take for the d sub y. Let's do that in red. We would take this answer column and we would substitute it in for where the y column was. And we would leave the x's alone, and we would take the determinant of that matrix. Same thing with the d sub z. If we're finding d sub z, we take that answer column, and we substitute in the z column, and then take the determinant. That's your numerator, and that's your denominator. The denominator, again, is the determinant of your original coefficient matrix. Divide them, you solve for your variables. Let's do an example. Let's say we're given this system of equations. We have a 2x plus y plus z equals 3. I'll do that to my z's. I know they look like 2's. We have an x minus a y minus z equals 0. And we have a third equation. That's going to be x plus 2y plus z also equals 0. All right, so there's our system. Now let's use Cramer's rule to find out what these x, y, and z values have to be. Okay. Well, first, we have to come up with the matrix here. Remember, the matrix is going to be the x columns are here. It's always the coefficients. So we have a 2, 1, 1. Don't forget it's a 1 if you don't see it. Our y column would have a 1, a -1, and a 2. And our z column has a 1, a -1, and a +1. That's the coefficient that's coefficient matrix. We're going to find the determinant of that, and that is the denominators there, the big D. Okay? And just so it's been said, the answer matrix would be right here. That would be 3, 0, 0. Okay? You get the answer matrix by having it in this fashion. Get the x's lined up, the y's lined up, the z's lined up, and have the number by itself on the right side, or the left side, but that's your answer matrix. All right, so the determinant, the big capital D, would be the determinant of this matrix right here. Don't forget the brackets versus the straight lines. Okay, this indicates a matrix. These indicate the determinant of that matrix. This is a value. This is a matrix. All right, well, in the interest of time, I mean, I've now shown you how to do these in the calculator, okay? So if you go ahead and plug this into your calculator, you are going to get a value of 3. Okay, great. And if you don't remember, if you don't want to use the calculator, you can watch the video on how we handled determinants to figure out how to do that manually. Okay, so great. So now we know the determinant is 3. Well, we have to find these 3 as well, d sub x, d sub y, and d sub z. Okay, let me make this a little bit smaller. I'm not doing, there we go. Okay, and this one over here. Oh, look at that. Proved the 3 right there. All right, different color, make it easier to see. So now for d sub x. D sub x. Well, like I said, that is going to be the same determinant, except we're going to take the answer column and substitute it in where the x column was. So that's going to give us a 3, 0, 0. And then everything else stays the same over here. 1, negative 1, 2. 1, negative 1, 1. Again, you can do that by hand, or you can plug it into your calculator. Well, actually, let me take that back. You need to know how to do both. At the end of this unit, we are going to have 2 exams. One exam you're allowed to use your calculator. The other exam, you are not allowed to use your calculator. So please, if you do not recall how to solve these manually, watch that other video again. This value right here is going to give me a 3 as well. That is nothing more than a coincidence, okay? Just a coincidence. All right, so fine. Now we have... So actually, before we continue, we can now solve for x right here. Oops, let me, right here. We can solve for that. X equals d sub x over d. Well, the d sub x we just found was 3. And the d itself, well, that was 3. So we now know that x equals 1. We're going to repeat the process for y and z. All right, let's try to clean this up a little bit, and then we'll deal with finding the y and the z. So let me, hang on a second, let me do this. Okay, and this. Just bear with me 1 second, I'm trying to make this easier on the eye. Okay, this should all be in your notes now, so. And if you didn't get it, rewind the video. Okay, so where are we at? Well, we did figure out that x equaled 3 over 3, and that's 1. Okay, now we need to find y and z. Well, we need to find d sub y. Again, d, we already figured out d, that was 3, so don't forget that. Now d sub y. Well, we're going to leave, again, it's the same determinant, except we change the y value, the y column now. So we have a 2, a 1, and a 1. The z's stay the same. That was a 1 and a negative 1 and a 1. And now what we're going to do is we're going to take that answer column and we're going to substitute it in for the y column. So that's going to be 3, 0, 0. Once you do that, if you do it properly, you are going to get a value of negative 6. Okay, the determinant for d sub y is negative 6. All right, so now we can solve for y. Y equals d sub y over d. D we already found was 3. D sub y we just found out is negative 6. And when we simplify it, we get our y value is negative 2. So now we know x is 1 and y is negative 2. Okay, let's make this a little bit smaller and do the last one. Let's change that. How about orange? Let's do z now. Well, again, we already know what this one is. We know what the d is. We need to find d sub z. And we just repeat the process. We are going to keep the x column the same. We're going to keep the y column the same. And we are going to substitute in the z column with that answer column. And find the determinant, and you should get a value of 9. If you did it correctly, it has a value of 9. So now, z equals d sub z over d. We found the d earlier, that was 3. We just found d sub z, right there, it's 9. And that simplifies to 3. And there we have it. We now know that x we figured out was 1, y is a negative 2, and z is 3. And there is the solution to our system of equations. I know I said watch the earlier video, but I can't help myself. I have to show you. All right, so just as a friendly reminder, we just figured out these x, y, and z's, okay? But by hand, the way we did it in class, right there is how I found the determinant manually. There's how I found d sub x. Okay, let me make that there and that there. Let's make some room, okay? And then d sub y. And certainly not last, but d sub z. Okay, so that's manually how I found each one. Okay, I'm not going to talk about them all. I'll just recap one of them, for example. And these are the answers right there. So for d sub x, we'll just use this one as our example. Let me do this right here. Okay, so for d sub x, what you do to find the determinant is you cross off, you take your heading here, you get your 3, your 1, and your 1. You put them there. And for the 3, if I cross out the row in the column with 3, I get this 2 by 2, and that 2 by 2 goes right there. I then repeat the process. I cross out the row in the column with the 1 in it, and I'm left with these 4 elements, 0, 0, 0, negative 1, 1. There's your 0, 0, negative 1, 1. And then again, you cross out the row and column for the last term, and you're left with these 4, which are over here, okay? And then what do you do? The last thing, don't forget, it is positive whatever that number is, negative whatever that number is, and then positive whatever that number is. We talked about 2 by 2 determinants. Solve it, and you'll get the same values we just discussed. My suggestion, if you're still stuck on this topic, pause this video, copy this down, look at it a bit. If you have any questions, ask me tomorrow in class. All right, let's do another example. We're not always going to be asked to find x, y, and z. Maybe we're just asked to find one letter. Let's find z in this example. Okay? So we have this system of equations. Let's call it 2x plus y plus z equals 1. X minus y plus 4z equals 0. And x plus 2y minus 2z equals 3. Let me make those look like z's. Okay, there's our system. Now let's solve for z. All right, well, remember, here are the equations right here. So I'll just leave these up here for our reminder there. We only need this one. Okay, we're finding z, so we have to find the determinant of the coefficient matrix and the d sub z. All right, let's do it. The coefficient determinant is this: 2, 1, 1, 1, negative 1, 2, 1, 4, negative 2. And the answer matrix, or the answer determinant, if you will, would be this: 1, 0, 3. Well, let me take that back. We're not really finding the determinant of that thing. That's the matrix, and we're going to be substituting that in. So let's call it a matrix. Okay, now, I mentioned this earlier, but just again, it's very important. Don't forget, you have to have it set up in this fashion. If these are not aligned, first do that. You must have your x's in one column, your y's, your z's, and your answers, all in those specific columns. Then continue. All right, well, let's see here. So let me make this smaller. This one too. Come on. All right, let's just do that. You can work with me. Okay, first, we must find the determinant, the coefficient determinant. Manually, it's right there. If you use your calculator, either way, if you do it right, you should get negative 3. Okay, great. What's next? Well, we need to find the d sub z. Don't forget, we're up here. This is what we're trying to find right here. So we have the denominator. Now let's find the numerator. Okay, so I'll make this smaller. Okay, there's the determinant. the coefficient determinant. Here is the d sub z. So notice, well, here, let me put it right underneath. Notice what we did here. The x column stays the same, the y column stays the same. The only thing was the z column now, we substituted in this answer column right there. Okay? So, after you find the determinant of that, you're going to get a value of -6. Again, if you need to look at this, pause this please, and just try to see my logic here. If this doesn't make sense, ask tomorrow. All right, well, now that we have our d and our d sub z, we do this. Okay? Divide and simplify, if you can. Sometimes you can't simplify. So, we now know that the d sub z is -6. We know the d is -3. This simplifies to 2. Z equals 2. All right, one last item here. Cramer's rule is nice and convenient and works most of the time, but it does not work all the time. It does not work when your coefficient determinant equals 0. If I find the determinant of that coefficient matrix and it equals 0, just as a friendly reminder, that means it is a singular matrix. Okay? Singular is when it equals 0. It doesn't work when that equals 0. Why? All right, well, let's take a look at these formulas here. You tell me why. That's right. The determinant is the denominator of x, y, and z. The only number we can't have there is 0. So if this value here is 0, we need to use some other method. Okay, hopefully that made sense and you took notes on this lesson. Be prepared to come into class tomorrow or the next school day, whatever it might be. And, oh yeah, there's my little trig guy right there. You might remember him from my PowerPoints. We're going to work on this right here. We just did Cramer's rule. So be prepared to work on that in class tomorrow. Okay? Have a great day.